Hey y'all, let's talk about solving equations with variables on both sides. Alright, so here is an equation with a variable on both sides. What shall we do? Well, this says we're going to subtract 2x from each side. Why would that help us? If we were to subtract 2x from each side, we would get rid of the x's off of this side. So then we would only have x's on one side of the equation. 2x minus 2x is 0. So we're just going to have 14 left on this side. And 5x minus 2x is 3x. So we got 3x plus 2 equals 14. And now this is something we know how to solve. We're going to undo the operations around our variable. So basically all we have to do if we had variables on both sides is pick which side to subtract them off of. Usually we do it with the side that has a lesser number of x's. 2 is less than 5, so we're going to subtract 2x's off of this side. It doesn't really matter. You could subtract 5x from both sides. The only difference is you'd have a negative 3x over here instead of a positive 3x over there. Alright, so now we're going to undo the plus 2 by subtracting 2 from both sides. And then we're going to undo the times 3 by dividing both sides by 3. And we get x equals 4. And then you can always check your solution just to make sure you're doing it right. Substitute your solution in for the variable. 5 times 4 is 20. 20 plus 2 is 22. 2 times 4 is 8. And 8 plus 14 is 22. Alright, so why don't you pause and see if you got this. Push play when you want to see if you got this. Alright, let's take a looky-loo. So we got 7k plus 2 equals 4k minus 10. And I've got k's on both sides, but I've got fewer k's over here. So I'm going to subtract 4k's off the right side and subtract 4k's off the left side. 4k minus 4k is 0, so that leaves me with 0 minus 10, which is negative 10 over here. 7k minus 4k is 3k plus 2. Now I want to get k by itself. I want to isolate my variable, so I'm going to subtract 2 from both sides of the equal sign, which leaves me with 3k equals negative 12. Then I'm going to divide both sides by 3, because 3 divided by 3 is 1, and that leaves k equals negative 4. Okay, now, gall darn it if I didn't already kind of answer this question, but let's go ahead and do it, and let's see how that turns out. So let's get our original equation here from number 1. 5x plus 2 equals 2x plus 14. And instead of subtracting 2x from both sides, let's subtract 5x from both sides and see what happens. 5x minus 5x is 0. 0 plus 2 is 2. 2 minus 5 is negative 3, so this gives me negative 3x plus 14. So kind of look, the only difference between this step and this step is that we have, instead of a positive 3x on the left side, we have a negative 3x on the right side. Okay, but we got our x right here. We need to undo the operations around it. We got a plus 14, so I'm going to subtract 14. 2 minus 14 is negative 12. And then I got a negative 3x left over here. And then I would divide both sides by negative 3. Negative divided by negative is positive 1, so this is 1x. Negative divided by negative is positive 4. And then by the symmetric property of equality, I can say that x equals 4. So compare and contrast. Well, compare, they are exactly the same solution. And contrast, well, we had more negatives, and we had to divide by a negative, and we had to keep track of things like negative divided by a negative is positive. So both methods are correct, but maybe this method is a little, maybe it gives you a little less chance to make a mistake because you have a little bit fewer negatives flying around. Alright, so graphic design. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer can complete each page in 1.25 hours. But it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? So the old way was 1.5 hours times the number of web pages. Let's let P equal the number of web pages. The new way would be 1.25 hours times the number of web pages you make plus 8 hours to learn. So if we set these equal to each other, we'll find out the number of web pages that make it so the new way is equal to the old way. So the equation we're going to use is 1.5p equals 1.25p plus 8. So what are we going to do here? We got p's over here and p's over there. We can subtract 1.25p from each side, because that will cancel them, clear them off of this side, because 1.25p minus 1.25p is 0. And then 1.5 minus 1.25 is 0.25. Now I can divide each side by 0.25. 0.25 divided by 0.25 is 1, so that's going to leave us with p. And then 8 divided by 0.25, that's dividing by a fourth, which is the same as multiplying by 4, so we get 32. So p equals 32. So that means if you make this, it's going to take the designer the same amount of time to make 32 web pages using either software. So if we switch to the new software, you have to make 33 pages in order to save time. Once you get past 32 pages, now you're saving time because it only takes you an hour and a quarter instead of an hour and a half. So whether you did it the old way or the new way, making 32 web pages would take you the same amount of time. But after 32, you would save time on each one with the new way. So why don't you pause it and see if you got it. So the office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill from $112 to $118. In how many months will the copier pay for itself? So we want to know, when does the cost of the copier equal how much money we're going to save, which is your monthly savings times the number of months. So the cost of the copier is $650. Your monthly savings is 112 minus 88. And the number of months is what we're trying to find out. So that's going to be our variable. So 112 minus 88 is 24. So we get 650 equals 24m. Then if we divide both sides by 24, 650 divided by 24 is 27.08. So we get m equals 27.08. But what does that mean? 27.08 months. It will take a little more than 27 months for us to break even. So that means that in 28 months, it will have paid for itself. In 27 months, it hasn't quite paid for itself. But in 28 months, it has paid for itself. So it'll take 28 months for the copier to pay for itself. Alright, here's an equation that has the variable on both sides, but we got grouping symbols too. What do you think we should do now? Well, you are correct if you said we should probably use the distributive property So let's go ahead and use the distributive property. 2 times 5x is 10x, 2 times negative 1 is negative 2, 3 times x is 3x, 3 times 11 is 33. Then let's subtract 3x from both sides. 3x minus 3x is 0. 10x minus 3x is 7x, so 7x minus 2 equals 33. Then we're going to add 2 to each side to get 7x equals 35. Then we're going to divide both sides by 7, and then we're going to get x equals 5. Cool. So let's see if you got it. Pause it and then push play when you're ready to see them worked out. Okay, so let's start with the distributive property. 4 times 2y is 8y. 4 times 1 is 1, so 4 times 1 is not 1. 4 times 1 is 4, so plus 4. 2 times y is 2y. 2 times negative 13 is negative 26. I got fewer y's over here, so I'm going to subtract my 2 y's off of here and off of the other side of the equal sign also. 8y minus 2y is 6y, so 6y plus 4 equals 2y minus 2y is 0, so we got negative 26 over here. Looking at my y, because I need to isolate it, it's got a plus 4 and a times 6. I undo addition and subtraction first. The opposite of plus 4 is minus 4, so I'm going to subtract 4 from each side of the equal sign. And I get 6y equals negative 30. The opposite of multiplying by 6 is dividing by 6, so I'm going to divide both sides by 6, and I get y equals negative 5. For b, distribute the 7. 7 times 4 is 28. Minus 7 times a is 7a. 3 times a is 3a. 3 times negative 4 is negative 12. Now you might look at this and say, well, 3 is smaller than 7. But in actuality, negative 7 is less than 3. So I want to get rid of the side that has less variable. So what's the opposite of negative 7a? We're going to add 7a. 28 minus 7a plus 7a is just 28. I'm adding 7a to both sides of the equal sign, and I get 28 equals 10a minus 12. I want to get my a by itself, so I'm going to undo the operations that are around it, starting with addition and subtraction. I have subtraction, minus 12. The opposite of minus 12 is plus 12. So I'm going to use the addition property of equality to add the same number to both sides of the equal sign. And then I get 40 equals 10a. Divide both sides of the equal sign by 10, and I get 4 equals a, or a equals 4, using the symmetric property of equality. Thunder snow. Thunder snow is your secret word, phrase, secret phrase. Yay. Alright, so an equation that is true for every possible value of the variable is an identity. For example, x plus 1 equals x plus 1 is an identity. Why is that true for every value of x? Because pick a number for x. 3. 3 plus 1 equals 3 plus 1, so 4 equals 4. Or think about it like this. If you were going to solve this, x plus 1 equals x plus 1, you would subtract x off of both sides to get rid of x off of one side or the other. But x minus x is 0, so you'd have 1 left on this side. X minus x is 0, so you'd have 1 on that side. So no matter what x was, you get 1 equal 1, which is always true. That means that this original equation is an identity. It means that we're equal to the same thing. This is equal to itself. Now, you can also have an equation that has no solution. For example, x plus 1 equals x plus 2 has no solution. If you were to try to solve this, you would subtract x from both sides. X minus x is 0, So I just have 1 left over here. X minus x is 0, and I have 2 left over here. Those are never equal. Never. So this means there's no solution. No solution means that there is no number you could possibly substitute into the original equation that would make it true. 1 doesn't work because 1 plus 1 is 2, and 1 plus 2 is 3. This equation right here is just never true. There's no solution for that equation. All right, so what is the solution of each equation? Well, we got to distribute over here, right? So when I distribute, I'm going to get 10x plus 12. And then if I subtract 10x from both sides, if I was to subtract 10x from both sides, I would get 12 equals 12, which is always true, right? And then you can also see it right here. 10x plus 12 is equal to 10x plus 12. That's an identity. So there are infinitely many solutions. Basically, you can put any number in for x. You could say that the solution to x is all real numbers. But we call that equation an identity. How about this equation? I think we should probably combine like terms over here. 12m minus 3m is 9m. And then they're just going to tell you right away, oh no, they actually do it. They say subtract 9m from both sides and you get negative 4 equals 5. Never. So this is no solution. No solution. Pause it and see if you can do these. All right. Let's distribute over here. 3 times 4b is 12b. 3 times negative 2 is negative 6. Equals negative 6 plus 12b. If you subtract 12b from both sides, you get 12b minus 12b is 0. So negative 6 over here. 12b minus 12b is 0. So negative 6 over here. So this is an identity. And it has, the solution is all real numbers. Has all real numbers as solutions. You can put anything you want in for b, and it'll always be equal. What about this one? Distribute. Let's see, over here we still got 2x plus 7. Negative 1 times 3 is negative 3. Negative 1 times negative 2x is positive 2x. Subtract 2x from both sides, and you get 7 equals negative 3, which is never true, so this is no solution. So here's a little summary. So in general, you can follow these steps. Start off with the distributive property to remove any grouping symbols. Also, you can use properties of equality to clear decimals and fractions. Clearing decimals, you're multiplying by 10 for every decimal place. And clearing fractions, you're multiplying by the common denominator. Step 2, you're going to combine like terms on each side. Step 3 is get the variable terms on one side. Step 4 would be to isolate the variable. And then once you have the variable isolated, that's your solution, and you check it in the original equation. All right, I think you know what to do now, and I'll see you later.